So we have this code which we will run on the Proteus. So first of all, it says this is the library which includes the input output definitions of AVR. इसके अलावा हमारे पास है DDRB 0FF. ये बेसिकली शो करता है कि हमने पोर्ट बी की सारी पिन को सेट कर दिया. 2FF मीन्स 111111. और आगे हमारे पास ये फॉर लूप है. लूप Z फ्रॉम 0 to 25 और ये राइट करेगा सारी पोर्ट बी की जो पिन है उसको. और इस कोड में हमारे पास बेसिकली जो एलईडीज होंगी पोर्ट बी पे वो चलेंगी फ्रॉम 0 to 255 और एंड हो जाएंगी 255 पे विच विल एंड सारी जो पिन होंगी जो एलईडीज होंगी वो 1 1 पे एंड हो जाएंगी और सारी एलईडीज ऑन होंगी एट द एंड ऑफ द कोड. तो इस कोड को रन करके अब देखते हैं. प्रोटियस पे इस कोड को हमने अब राइट कर लिया है और सक्सेसफुली कंपाइल भी हो चुका है. अब इसको रन करके देखते हैं. अगर हम स्कीमेटिक कैप्चर पे देखें तो ये पोर्ट बी की आप देखें सारी पिन्स किस तरह से टॉगल कर रही थी और एंड जिस तरह से मैंने आपको कहा था कि स्टार्ट होगा 00000000 से और एंड होगा जब सारी पिन्स 1 हो जाएंगी और 1 मतलब कि ऑन होगी सारी एलईडीज. तो एज यू कैन सी कि पोर्ट बी IO13 पे जिस तरह से ये एलईडीज लगी हुई हैं और ये एंड हुई है सारी ऑन पे. As we move on to the next code, ये कोड बेसिकली शो करता है कि हमारे पास array है which contains these characters from 0 to D, 0 1 2 3 4 5 A B C D. और अब पोर्ट बी के सारे पिन्स जो है वो सेट हो गई है टू FF और यहाँ पे भी सिमिलर टू द प्रीवियस वन लूप थ्रू द फर्स्ट चलेगा और इनके बेसिकली जो करेक्टर्स हैं फ्रॉम 0 to D इनके ऐड की करेक्टर्स शो करेगा हमें कोड में. सो लेट्स रन दिस कोड ऑन द प्रोटीन. सो यू कैन सी ये कोड हमने लिख लिया. अब इसको कंपाइल करते हैं. नाउ हैव अ लुक एट इट्स स्कीमेटिक. ये कोड स्टार्ट हुआ था बेसिकली जो करेक्टर्स हमारे पास थे वो थे 0 to D. तो 0 से स्टार्ट हुआ था और एंड इट विल हैव टू एंड इट एट D. तो अगर हम D की ASCII देखें तो इन बाइनरी सो इट शोज के जो सेकंड उसका करेक्टर है इन द बाइनरी that will be 1 and the sixth pin will be 1. So that's how the LEDs be in the second place and then the sixth place. The sixth pin is 1, so that's why LEDs are on at these positions. हम इसका ASCII table भी देख लेते हैं. Now if we have look at the ASCII table of D, uppercase D, we had D and the final character which we have to show. So ये यहाँ की इसकी बाइनरी है. तो आप इसको देख सकते हैं. इसकी सेकंड जो पिन है वो ऑन है और सिक्स पिन ऑन है. दैट्स व्हाई सेकंड एलईडी और सिक्स्थ एलईडी वर ऑन. लेट्स मूव ऑन टू द थर्ड कोड. इस कोड में बेसिकली इनिशियली हमने सारी पिन सेट की है और इनिशियलाइज किए हैं पोर्ट बी की पिन को टू A which in binary you can write as 0 1 0 1 0 और it will basically toggle on bits of port B 200 times. like ऑन है तो ऑफ हो जाएगी, ऑन है तो ऑफ हो जाएगी, ऑफ है तो ऑन हो जाएगी. और फॉर एग्जांपल कि हमारे पास जो वहाँ पे बिट्स का नंबर आता है जिस पे एलईडीज ऑन ऑफ होंगी. फॉर एग्जांपल एट दिस स्टेज जो एलईडीज का पैटर्न है वो है 1 0 1 0 1 0 1 0. So at the next instant वो इन्वर्ट हो जाएगा. It will invert to 0 1 0 1 0 0 1 और ये 200 टाइम्स रिपीट होगा. आफ्टर 200 टाइम्स जो लास्ट स्टेट होगी टॉगल करने की that will be shown and at that moment the LED will freeze. जो भी टॉगल मोमेंट होगा वहाँ पे एलईडी उस पे फ्रीज हो जाएगी। तो अब इस कोड को हम रन करके देखते हैं प्रोटेस। सो वी हैव रिटन दिस कोड ऑन द प्रोटेस। अब इसको हम रन करेंगे और विल सी के जो लास्ट उसकी स्टेट होती है टॉगल की, उसमें एलईडीज किस तरह से होंगी। So that's how the LEDs are shown at the last state, the 200th state. First LED, third, fifth और seventh LED means जो odd LEDs हैं वो 200th पोजीशन पे ऑन रहेंगे और बाकी ऑफ रहेंगे। इफ फॉर एग्जांपल अगर ये 201 टाइम चलता तो सेकंड, फोर्थ, सिक्स्थ और एट्थ जो इसकी पिन होती, एट्थ एलईडी होती, वो ऑन होती। नाउ लेट्स हैव अ लुक एट दिस कोड। इसमें बेसिकली हमने वही काम किया है, सेट किया है पोर्ट बी की पिन को और इसमें इनफिनिट लूप हमने लगाया। बेसिकली जो भी लूप चलेगा वो दोबारा से अपनी इनिशियल पोजीशन पे आएगा और वो उसी तरह रिपीटली चलता रहेगा। इसमें हमने एक और चीज़ ऐड की है कि बेसिकली इसमें हमने डिले ऐड किया है 500 मिलीसेकंड और पोर्ट बी बेसिकली एज अ काउंट अप वर्क करेगा। It will start from 00000000 to all pins 1. So let's work out this code on the Proteus. So आप इसकी schematic देख सकते हैं। Let's have a look at these pins. ये किस तरह से टॉगल कर रही हैं। बेसिकली ये स्टार्ट होती हैं all from 0 and move up till all pins become 1. लेकिन फिर ये दोबारा से अपनी इनिशियल स्टेट पे आ जाती हैं। दिस इज कॉल्ड द स्मूथ काउंट अप। बेसिकली ये काउंट एज अ काउंट अप यूज होती हैं और अगर हम इसकी लास्ट स्टेट देखें एट द 255th तो हाउ द एलईडीज विल रिएक्ट। ऑफ कोर्स सारी पिन्स 1 होंगी तो एलईडीज भी सारी ऑन ही होंगी। Port C and port B and D will be defined as the pins of them will be defined as output, and then we'll read the value from port C that will be storing the data in the file. And it is basically a simple C++ code. If the value in the temp will be less than 100, it will show port B, the LEDs on port B will turn on, else the LEDs in port D will be turned on. The LEDs will update dynamically based on the input values from port C. And for example, if temp is equal to 50, port port B LEDs will show 50 in the binary. Basically, the result will be shown in the binary form as there are 8 LEDs in each port. So if there is 50, so the binary value 50 will be shown in the port B, and if the value is 150 in the temporary file, the binary value of 150 will be shown in the port B as in form of LEDs turning on or off as per the number which is stored in the temporary file. And now if we move on to this code, we can see the all pins of port B, C and D are set as the output, and port B perform bitwise and between bit 5 and 0x0f, and port C perform the operation or between the 0x04 and 0x8, and likewise port D is performing XOR. This is the symbol of XOR between 0x54 and 0x78, and the port B will perform bitwise NOT on 0x55. This is the symbol of NOT, infinite loop. Along with that, in the port B, the LEDs will display uh, in binary as 0x5 and then display as 0xAA, and in port C, LEDs will be displaying as 0xC. If we perform the OR between 0x04 and 0x08, display as 0xC, and it will be displaying obviously in the binary. And if you talk about the XOR function between 0x54 and 0x78, so it will be displayed as 0x2C, and all of this will be displaying in the binary, and bits which will be 1 will be turned on as the LED. So let's see it in the Proteus. So the code has been compiled. If we talk about, this is the port B. So if we talk about, saying that uh, 0xAA and 0x05 will be turned on, and it will be displaying, initially it was 0x05, and then after performing the AND, 0xAA will be shown, and the binary of it will be 10101010, and you can see the bits which are odd are turned on: 10101010. So the port B has shown the function which has performed the AND operation. And if we talk about port D, so it was it was displaying 0xC, and in binary it is like 00101100. So as you can see here, 00101100. And similarly, as we were talking about port C, it was displaying 0x60, which is in binary 01101100. So 01101100. So that's how these operations are performed, and these LEDs are turned on. So moving on to the example 717, we can see the port B and D are defined as input and output, and Z, this reads the value from port B and stores it in Z, and Z is equal to Z, and this is the binary value of it. It keep only the lowest two bits value from 0 to 3 as on, and the switch Z, it will basically take the values of Z and writes the ASCII value of 0, 1, 2, or 3 to the port D based on the case. So basically, LEDs will react like if Z is equal to 0 and port D shows 0. So the ASCII value of 0 will be shown, and the binary of that specific ASCII value will be shown as the output. For example, if the value of Z is 1, and the port D shows 1 in the ASCII, and the ASCII of 1 is, let's check it on the ASCII table. So you can see the ASCII value of 1 is 49. So if ASCII is 1, the value, if port D shows 1, ASCII value 49 will be shown, and it will be displayed uh, in the binary. And the binary of 49 is 00110001. So that result will be shown on the Proteus. So let's check on to the next one. It basically shows that it sets the PB, the port B, pin 5 as input by claiming its bit in the DDR register. And similarly for the port C, it sets the pin 7 as output, um, setting its bit in the DDRC register, and it is the infinite loop. And this basically shows X if PB5 is high, like it has the logic 1. Um, it will set PB like PC7 is set high using port C, this one, else it will use this one. And LEDs which we have attached on schematic, if an LED is connected to PC7, it will turn on when PB5 is high and turn on when PB5 is low. And this will basically create a direct control relationship. LED on PC7 mirrors the state of input at PB5. So moving on to the next code, it also define LED7 as over here you can see, and define sensor as a pin 1 and LED as pin 7. Here it sets port B pin 1 as input by uh, clearing its bit in DDRB, and over here it basically sets the port C pin 7 as output by setting its bit in DDRC. So it basically if PB1 is high and if PB1 is high, and similarly if PB1 is low using this, and if an LED is connected to PC7, it will turn on when PB1 is high, turn off when PB1 is low. So this will be creating similarly as the previous code, direct control relationship. The LED on PC7 mirrors the state of input at PB1. So let's have a look at this code. In this, basically, it will set all pins of port B and C as output, and unsigned character my byte initializes my byte with the value of this in the binary, obviously, and X my byte. This will basically X the lower nibble of and which is basically 0x09, and port B it will perform basically combines the lower nibble of 009 with 0x30 to convert it to an ASCII character now and write it to the port B. And why my byte and 0x F0 extracts the upper nibble, which is 0x20, and this y is equal to y greater than 4, basically shift the upper nibble right by 4 bits to get the value, the specific value. And port C it basically combines 0x02 with 0x30 to convert it into an ASCII character, uh, whatever it will be, and write it to the port C. So basically, the port B LEDs will display the ASCII value of a 9, which they will get from port X03 while combining the lower nibble with the 0x30 and while converting it into ASCII. And port C will display the ASCII value while they will be converting the ASCII character when they will combine the upper nibble 002 with 030. As we run this code in the Proteus, uh, we can see, as we know, the values on port B LED will display the ASCII value of 9, and the ASCII value of 9, let's see it in the ASCII table. So here you can see ASCII of 9 is 57, so the binary of 57 will be shown, and on the port C, ASCII of 2 will be shown. So ASCII of 2 is 50. So binary of 50 and 57 will be shown, 50 on the port C and 57 on the port B. So the 57 ASCII on over here on port B is 00111 as these LEDs are turned on, and for the port C we have the ASCII value of 2, which is 50, and it is in binary. If we convert it into the binary, it is 0011 0010. So that's what it shows in the port B, the ASCII of 9, and in the port C, ASCII of 2. So moving on to the next code, this code basically explains initially the port B values. The pins of port B are all set to output, and over here the unsigned character W for it initializes basically the W with ASCII value of 4, which is basically 0x34. We'll discuss that later on while seeing it on the ASCII table. An unsigned character Z, it initializes the Z with ASCII value of 7, which is basically 34 plus 3, 37. And over here you can see W and 0x0f. It basically extracts the lower nibble of W, the value of 0x04, and over here it shifts the lower nibble left by 4 bits. And in Z and 0x04, it basically extracts the lower nibble of Z, 0x07, and BCD by W or Z. It combines the shifted W and Z to form BCD byte value, and the value of BCD byte is 0x47, and basically it will write that value on the port B. So port B LD will basically display this value, the BCD byte value, which is 0x47, and of course in the binary. So binary of 47 is 01000 and 111. So this value will basically be shown on the port B. So as you can see, the code has been compiled, and the value of 0x47, which we got from the BCD byte after combining the shifted W and C to form that BCD byte, we got the value 0x47, and that will be basically displayed on the port B in the binary form. Binary of 47 is 01000111. So this is the value of BCD byte which has been displayed on the port B. So let's have a look at this code, which is example 731. So in this basically it fits all of port B, C, and D as output, and this basically defines the line 9. It initializes DIM byte with the value of 0xFD. And the decimal of this is 253. 253 is the decimal of FD, and x is equal to bin byte by 10. It basically divides this value by 10, and D1 is equal to bin byte. So this basically stores the remainder of bin byte. When we divide 253 with 10, it is basically 25, but remainder remain is 3, so it will be stored over here in D1. And D2 basically stores the remainder of x by 10, uh, which will be 5, and D3 dividing x by 10 and storing the results of it. So over here, port P will be storing the value of P1, which we will get from here, it is 3, and port C will be storing the value of D2, which is 5, and port D will be storing the value of D3. And similarly, in the schematic, the LEDs will display these values, like port B stored the value 3, so it will show the binary value of 3, which is 0, 1, 1. Initially, the first, the least 2 bits will be turned on, and port C will be displaying uh, its specific binary value, which is stored in P2, and P3, the port D will show the specific uh, binary value which is stored in D3. It was 2, so the binary value of 2 will be shown in the port D, and those specific LEDs will be turned on. Let's have a look of this code in the Proteus. So let's compile this code. So have a look at its uh, schematic. The value of P was stored in port B, so its least 2 bits are turned on. 1, 2, 4, 8, 16. So 1, 2 is turned on, 1 plus 2 is 3, so 3 is turned on. And for port D, the value was 2, so the second 1, 2, 4. So 2 is turned on, the second placed LED. And similarly, for the you can see port C, these these values are turned on for the value of on the port C was 5, the value of D2 was 5. So the binary 5 is turned on and displaying it as the LEDs are turned on. So looking on to the last code of chapter 7, we can see here it defined the SER pin as 3 over here, as pin 3, SER pin as pin 3, and over here it sets port C pin 3 as input by declaring its bit in the TDRC register, and unsigned character REGA is implied to 0. Over here you can see the for loop, it's showing that loop 8 times to read 8 bit from PC3, so it will read 8 times, and REGA is equal to REGA greater than 1. It basically means the shift right by this bit. If over here it's 4, it will be meaning that it shifts REGA right by 4 bits. So over here it's 1, so it will shift it by 1 bit to the right, and over here it basically defines that it reads the state of port C pin 3, shift to the appropriate position, and combines it with REGA, and of course while loop it stops the program in an infinite after reading the 8 bits. So in this code, it does not directly control LED. It reads 8 bits serially from port C to 3 and store them in RGA. So now coming on to the chapter 9, we have the timer codes over here. So initially, over here you can see it sets all pins of port B as output, and then we have the while loop, and it writes 0x55 to port B and 0x88 to port A, and the delay is called in both. It basically calls the delay function again for another delay. Here you can see we have two delay function, and ECNT0 is basically loads the timer 0 counter with 0x20, and TCCROA is basically configures uh, timer 0 in normal mode. It basically shows it in the normal mode, and TCCROB it basically starts the timer 0 with no grayscale as it is mentioned in the comment over here, and uh, in the while loop it waits for timer 0 to uh, overflow over from 0x to 0x00, and PCCR when it is equal to 0, it means the timer 0 will stops, and over here it will clear the overflow flag. So all in all, it's the code. If we uh, go for the LEDs connection and the schematic, so in port B, LEDs will alternate between 0x55 in binary, obviously, and 0x88 with delay between each states, and the delay duration is determined by the timer 0 overflow, uh, which depends on the clock frequency initial value of PCNT 0 to 0. This is the initial value. So as you can see in the schematic, the LEDs are turning on. First, it's the LEDs of 0x55. 0x55 की जो LEDs हैं वो है 01, 01, 01, 01, और देन 0x की LEDs ऑन होगी जो बिल्कुल उससे ऑपोजिट है, इन्वर्ट हो जाएंगी 1010. So that's why you can see over here it's in inverting mode, you can say. बार बार ये इन्वर्ट हो रहा है, जो ऑफ था वो ऑन हो रहा है, जो ऑन था वो ऑफ हो रहा है. सिमिलरली यू कैन सी इन द पिंस, जो ब्लू था वो रेड हो रहा है और जो रेड था वो ब्लू हो रहा है. सो इट मीन्स कि इट्स बीन चेंजिंग from 0x55 to 0xAA. So as we move on to the next code, which is 940. तो इस कोड में बेसिकली उसने सारी पिन जो पोर्ट पे किया उसको एज आउटपुट सेट कर दिया, इनफाइनाइट लूप लगाया है, और calls it has called the to delay function. It is basically to create a delay, or over here you can see this is basically the toggle bit 4 of port B using XOR. ये XOR का symbol है over here, ये XOR का symbol है. If PB4 is high, मतलब port B की जो fourth pin है वो high होगी, it becomes low and vice versa. और ये to delay function है, इसमें PCNT को basically 186, it basically loads the timer 0 count with 186, which correspond to -70 in the 8-bit sign. और ये बेसिकली ये जो लाइन है ये हमें बेसिकली बताती है कि timer 0 is in normal mode, and 0x22 is start timer 0 with a prescaler of 8. For while loop आगे लगाए, it basically wait for timer 0 to overflow, and then we have this, it will stop the timer 0 and then clears the timer 0 overflow. बेसिकली इस कोड की जो हमारे पास LEDs होंगी लाइक पोर्ट बी बिट 4, वो टॉगल करेंगे ऑन ऑफ विद डिले. ऑफ कोर्स वी और वो ऑफ कोर्स क्लॉक फ्रीक्वेंसी पे ही डिपेंड करता है। एज यू कैन सी इन द schematic जो फोर्थ पिन है पोर्ट बी की वो टॉगल हो रही है। सो दैट वाज ऑल अबाउट द फंक्शन। अब जो इसके बीच में डिले है वो डिपेंड करता है टाइमर 0 पे कि वो कितना होगा। एंड दैट वाज ऑल ऑफ दिस कोड। काफ़ी बेसिक सा कोड था। और लेट्स मूव ऑन टू द नेक्स्ट वन। सो हैव अ लुक एट दिस कोड। इसमें भी DDR भी सारी पोर्ट बी की जो पिन्स हैं उसको एज आउट सेट किया है। वाइल लूप गेम इनफिनिट लूप और यहाँ पर इट बेसिकली टॉगल्स बिट 4 ऑफ पोर्ट बी यूजिंग XOR। और ये वही वाली चीज़ है एज इन द प्रीवियस कोड। और इट कॉल्स this thing basically calls the P1 delay function to create a delay। ये हमारे पास P1 delay का फंक्शन है। एंड इसमें जो TCNT1 है it basically loads a high byte of timer 1 with 0xC1 और जो जिसके साथ L वाला है it means it loads the low byte of timer 1 with 0x80 और TC TCCR1A basically यहाँ पे शो कर रहा है कि timer 1 is in the normal mode and TCCR1B basically shows that timer 1 is with no pre-scaler। यहाँ पे आगे while का loop आ जाता है which basically waits for timer 1 to overflow and TCCR1B again it stops the timer 1 and plays over here it plays the timer 1 overflow flag in the schematic when this code will run। जो fourth pin होगी port B की that will toggle with the delay। The delay duration again it is determined by the timer 1 overflow and it depends on the frequency of the initial value of TCNT1 और ये similarly जो previous code था उसी की तरह वर्क करेगा। There will be no difference। Moving on to the next code, it's 942। So as you can see over here, again जो bits है port B की, they are all set as an output and along with that we have infinite loop। फिर यहाँ पे जो fourth bit होगी port B की that will be toggled using XOR and if PB4 is high it becomes low and vice versa। It was previously done in the program 940 और यहाँ पे भी वही P1 delay यूज किया गया है to it basically calls the function to create the delay and moving on forward we have this function in which the TCNT1 hatch which basically loads a high byte of time and TCNT1 H and L basically define byte है वो high H means high and alternatively C2F7। It also can be used to load the 16-bit timer with one 0xC2F7 like combining them together। Moving forward, this basically shows we are in the normal mode and it starts the timer with a prescaler of 1024 and while it basically wait for the timer 1 to overflow and then the timer 1 will stop and clear the timer 1 overflow flag। इसमें भी basically there is not a huge difference between the previous code and this one. Port B की जो fourth bit होगी that will dominate with the delay between and the duration will be determined by the time of course the clock frequency. Overall, if we summarize this code, it basically shows that it will the code basically toggles before with the delay created by timer one, and the delay is based on the timer one overflow, and the LEDs are connected to P before while and they will keep blinking indefinitely. And that was all happening in the previous two code as well. Moving on to the further one, this is the last code, number 9. So this code basically shows us that it enables the clock register on port D pin 4 and set all pins of port C as output and all pins of port B as output as well. And over here it configures time 0 in normal mode and PCCR 0B. It basically shows that it starts timer 0 with an external clock source on the falling edge of T0 PD4 and PCNT it initializes the counter to 0x00 and further we have the loop. It basically continuously writes the value of TC and T0 to the port C. As you can see over here, it is continuously writing it and wait for timer 0 to overflow. Over here, it clears the timer 0 overflow flag and increments the value of port B by 1. The port C basically will display the current value of TCNT0 in the real time, whereas the port B will increment by 1 each time timer 0 will overflow. So in the schematic, we will have LEDs on port C and D, and LED on port C will display the current value of TCNT0, and port B, the LEDs on the port B will increment by 1 each time the overflow will occur. So let's check it out in the schematic. And as you can see, initially, as it was defined, pin C, pin 4 of port D was defined. Here you can see, and in summary, basically this code uses timer 0 in normal mode with an external clock source and like falling edge on PD4 and both LED show the timer 0 counter value and port B basically increments each time when timer 0 overflows. And this program runs indefinitely, continuously, updating the LEDs based on the timer zero's behavior, as it was previously mentioned in the main loop over here. It basically continuously writes the value for the port C and wait for timer zero to overflow and plays and in the end it is all same. It plays the timer zero flag and over here implementing to the port B. So that was all from the chapter number 9.